A unit vector is a vector with length 1. So let's say we start with some arbitrary vector, and we want to make a vector out of this that has length 1 but which points in the same direction. Then we could just take A and divide it by its own length, because then we make a vector that has the length of 1. So then we just get a new vector pointing in the same direction, but now this has a length of 1. So the length of this one is equal to 1. So this is an example of a unit vector. And often you write a unit vector with the letter E. So you can write it like this. And if you want to make a notation that this is a unit vector pointing in the same direction as A, you could write an A here. So we have that unit vector in the direction of A is just given by this. And we have here that the length of this vector is just equal to 1. So if you have a vector, you can always create another vector pointing in the same direction but has a length 1. Multiplying both sides here with the length, we see we can also write this as that any vector can be written as take its own length, then multiply with the unit vector pointing in the same direction. Any vector can be written in terms of the unit vectors pointing along the x and y axis. For example, here we have a unit vector that we could call EX, since it's pointing in the direction of the x-axis and has a length of 1. And we can also draw the unit vector in the y direction. Also, of course, has a length of 1 and points in the direction of the y-axis. So we can call this EY. Then any vector in this coordinate system can be represented in terms of these two. For example, if you have this one, the vector 4, 3, then that can be written as a combination of these two. So here we have the vector V, 4, 3. And this vector now can be written as a combination of these. So we have that V is equal to 4, 3. But 4, 3 we can write, if you want, as 4, 0 plus 0, 3. You split them up like this. And this we can write as 4 times 1, 0. And this we can write as 3 times 0, 1. But then we see that the components of EX, what is that? That is just a vector pointing one step in the x direction and 0 in the y direction. And EY is just a vector pointing one step in the y direction and 0 steps in the x direction. So we have the components here of those vectors. But we see that's just those vectors here. So we see here that we have 4 times EX. And here are 3 times EY. And here, these numbers were just arbitrary. So of course we could just change them to anything we like. So let's generally call them VX, VY. Just repeating this thing, we see that we can write it like this. So all vectors can be written as a combination of these two basis unit vectors. And therefore this is called a basis for this coordinate system, because every vector in this coordinate system can be expressed in terms of these two.